Okay, welcome everybody. I believe I have turned off the music. That was my first time trying hold music. If you still hear it, please let me know, but I don't hear it on my end of the stream, so I think we are okay. Welcome everybody to the first online class for PHYS 151 General Physics Mechanics. I hope everybody in class is safe and healthy and isolated. This switch to ending our semester online certainly caught a lot of us by surprise. None of us thinks this is an ideal arrangement, and so we are all just going to work together to make the best that we can. As I said in my email to you, your top priority right now should be your health and safety, both physical and mental. I do not expect this class to be your top priority. I don't expect it to even be in the top 50% of your priorities right now, as everybody in the world deals with this pandemic. However, I do want us to be able to finish the semester as well as we can. I want you to feel like you got your tuition's worth. I want you to feel like you are prepared for the next classes you need in your in your educational journey. And so that's why we're here today, is to get that started. We have about a month left of the semester. We really don't have that much to wrap up this spring term. We're going to go over what the changes are to the class, but there really is not that much left to do, and you all pretty much know what you're doing at this point. And so I'm confident that each and every one of you can wrap this up well and finish these last couple of activities, do this final project. I'm confident you can all do that with what you have learned so far. With that said, if any of you feel like you don't have access to the appropriate resources that you need, if you left your laptop on the JU campus and you're now on another continent, if you don't have any means of doing video analysis, if you don't have any means of getting access to Trinket, please let me know. We can make whatever adjustments are needed to make sure you get the last couple concepts that you need this semester. So one of the ways we're going to adapt to this brave new world is with a weekly live stream for class. Our class sessions, as you know, are mostly activity-based anyway, and so you're accustomed to working on your own on this. We're just a little bit more removed from each other now. During these live streams, you can comment in the chat window. The stream is delayed by about 10 to 20 seconds, so if you post a question in the chat, you're going to hear me continue to talk for a little bit before I can see it, or before I have seen it and respond to it. So please, 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 as we go through, if there's something that we go over that doesn't make sense, if there's something you think I left out or that I skipped, or something you want to know about, or that you just want to give feedback on, please use that chat window. These streams are also going to be recorded, so that folks who are unable to join us live can watch the recording later. Live is certainly better because you can ask questions in real time, but thank you, Edie, for that question. I don't anticipate we will, I don't anticipate that you being here live is going to be essential to the rest of the class. Edie has asked, is Letter 9 Home still due this Friday? Let me answer her. No, all letters home will be due on April 20th. There we go. And we are about to actually go over that in just a second. I'm going to send you a couple links to some useful resources. First is our syllabus addendum. So rather than rewrite the entire syllabus, I've just summarized the changes in this Google Doc that I've just posted the chat. And then in a few minutes, we're going to get over to a whiteboard, Google's Jamboard, an unfortunately under-advertised resource in Google Drive. And that'll sort of be our common whiteboard together. So I thought what we could do for today would be go over what the changes are to the course, including deadlines and all of that stuff. And then we'll take a look at the topic for this week, which is rolling motion, which is one of my favorite topics for the semester. So let's see. So let's take a look at this document together. Like I said, I assume that you are going to make your priority your health and safety. Course expectations, learning goals, deadlines, those are all understood to be flexible. Please understand that. Let's see. Actually, I need to update this, don't I? Because I made this assuming that we would be going back to campus on April 3rd. However, it seems we will not be going back to campus until June 20th. So the following adjustments are made. I will adjust that off camera. I will make a comment to myself to adjust based on recent extension of online learning. There we go. So just ignore that paragraph for right now. Let's see. So the first thing we'll look at is the weekly checkpoint activities. You're all going to receive credit for checkpoints 10 and 11. Thank you to those of you who sent in checkpoint 10. I know that was due this past Monday when I was still getting our adjustments together, but basically everybody's going to get free credit for those two because, it's just easier if we don't have to worry about them. Submitting them is not required. When it comes to the letters home, did I say April 15th? Excuse me. Yeah. So when it comes to the letters home, as you know from the syllabus, you're expected to complete 10 out of 11 letters home, which means you have in principle completed 9 of those. Some of you are missing 1 or 2. Some of you are missing a lot more than that. And I probably need to hear from you about how you're going to complete those. But you really only have 2 activities left. And if you're satisfied with how you've done on letters home so far, you can even take one of these 2 as your drop and make life easier on yourself during the pandemic. I should also say that for any letters home I have not graded, I am probably going to err on the side of grading more graciously, if that makes sense. My recommendation is that you complete the activities for weeks 10 and 11 by April 15th. That's not when I want you to have the letters home done. That's when I think you should probably be done with the actual recording, data analysis, coding, things like that. The things we would have done in class. I'm asking you to submit a letter home about those. And basically all the letters home are going to be due here at 10 a.m. on April 20th. So that is, I think that's a Tuesday. Let's check the old calendar here. That's a Monday. Yeah, that's the Monday of final exam week. So that is the day that stuff would have been due anyway. If you find that you need more time than that, just let me know. We can be flexible with these things. Basically, 10 a.m. on April 20th, that's when I'm going to open them up and start grading them graciously and get start to get the final grades together. Courtney has asked how to record the video for this week. That is an excellent question, Courtney. Let's get to that when we get over to this week's content. We'll make sure we get to that. So basically all outstanding letters home are going to be due Monday, April 20th at 10 a.m. And like I said, that's when I will start to assess them. So please take your time on those. If you're not able to get a video analysis or whatever together, this week, it's not the end of the world, right? This basically gives you a month to do 2 activities, right? Let's see. The other piece of the grade we need to look at is the feedback participation. You are still expected to complete 4 feedback participation activities, but the list is going to be expanded, right? So this was, you can go to office hours, go to tutoring, or to a peer review. Well, I no longer am in my office, and you're not on campus either, I hope at this point. Their tutoring is moved to online, so things are a little bit different now. So we're going to call participation in class live streams an opportunity for feedback participation. So this right now, if you are here listening to this, you've got a feedback participation. All you need to do is grab a screenshot as documentation. So if you're on a mobile device, I know on Android that's power button and down button. If you're on a Windows device, that's the print screen button. Or honestly, these are going to be recorded, so you could just grab a screenshot off the recording. Anyway, participation in online office hours. So I'm going to have office hours every Monday and Friday through Google Hangouts. You take a screenshot of being at that, and that will count. Participation in online tutoring. JU has set up for you to have access to online tutoring. The details for that have been emailed to you from the university itself, so I'll trust that their instructions there are self-explanatory. If you have questions on that, please contact the appropriate office at JU. Again, just grab a screenshot, send it to me, and we'll call that documentation. Or participating in a group chat with a classmate. You know what? I don't even care if you're talking about physics. If you are just catching up and talking about how to keep yourselves entertained in isolation, that's great too. Again, just send me a screenshot as documentation. I'm asking you to avoid meeting in person because that's the whole point of us not being in class. And then participating in a letter home peer review is still accepted as usual. So anyway, that's the adjustments to feedback participation. If any of that doesn't make sense, please let me know in the chat window and we can revisit that. Adventures in Atharia. Would you like us to, okay, Shashan is asking, would you like us to just email you the screenshot? Yes, please. There we go. Sure, Courtney, we'll say comments to count documentation. Sure, there we go. I should be able to retrieve the comments afterward. If I can't, I will let you know. Let me see. Here, I will make a note to myself. Control-Alt-M. WBL, check on whether can access comments. There we go. I mean, that would be easy, right? We could just all comment present, right? Wouldn't that be easy? All right, so Adventures in Atharia. Thank you all for indulging me in playing this little game I'm designing. You're all going to receive full credit for this portion of the grade. I hope you enjoyed it. Courtney has asked, can we play AIN over Zoom chat? You are certainly welcome to. In fact, there may be folks in technical communication who are looking to run a game for a play test. They can certainly, put out a call for participants here or on the GroupMe chat or wherever. Yes, if you would like to organize an online game of that, you are certainly welcome to. Let's see. The last one, the biggie, is the adjustment to the final project. We are still going to conduct this. We're going to scale it down a little bit. So instead of requiring you to work in groups, you can work alone or in a team of up to 3 people. I don't expect any of you to be present together, so group work is going to be a little bit more complicated. So yeah, you can work alone on the final project or in a group of up to 3. Again, please meet in person only as infrequently as possible, preferably none. I'm recommending that you go ahead and get started on that final project by completing a few steps. We can even get started with that here. First step, if you want any teammates, is to select your teammates. So if you want to work alone, you are selecting 0 teammates, right? If that makes sense. You can email your classmates. I've sent out plenty of emails. You can reply to them, or you can call for partners on GroupMe or here in the chat. I'm asking you to select a topic from this list. So if you want to click on that link here, I'll even put that in the chat. Call that Final Projects. There we go. Courtney needs permission to view the documents. I thought I had those on all documents. Link can edit. Courtney, try that again. They should be on. Everybody has them viewable. Anyone with a link can view. Anyone with a link can view. So Courtney, just try that again. Make sure you're in the folder for this semester. So anyway, here are the topics that you'll get to select from. What I'll ask you to do is just select the topic that you want and then leave a comment with your name. So let's say, for example, you are interested in doing capture code and compare a billiards shot. All you do is select that, click on add comment, and say WBL or WB Lane gets this one, exclamation mark. Now, of course, I shouldn't be doing that project, so I'm going to delete that comment. But yeah, that's all you have to do there is just claim your project. You can even do that now while we are discussing business. I'm going to guess nobody has pass cars and Lego figures, so let's make this generic cars. Okay, cool. So yeah, so you can select things from there. There's all sorts of stuff on here. There's stuff that involves the entire capture code compare process. There's some stuff that just requires a simulation. There is, you can add relativity to any one of our codes. You can build a simulation based on a CGP Grey video. Let's see, you can make a tutorial for future students. If there's something about VPython or Tracker that you didn't understand that you think you can give a better explanation of, I would love to see tutorials. By the way, if you have honorized this class, this is your project right here, is making a tutorial video. You can, if you really liked your time in Adventures in Netharia, you can design a creature or an encounter. If you are in technical communication, you have to design a different creature or different encounter than you did for that class. But you've already been through the process there, so you have an idea of what to do there. And this one was just added this week. Modify the classic SIRS model to accurately depict spread of COVID-19. Okay, so that's the topics for the final project. Let's talk about what you're going to do with this thing. So you're going to work on this project. It's pretty much an extension of the stuff you've done in class. So it's the same type of analysis, that you do every week in class. You are not expected to do this on your own and just present a presentation magically at the end of the semester. Please ask me questions over email, over GroupMe, online office hours, etc. Any way you can get a hold of me about the project. I've even dumped a cell phone number at the bottom here. Okay, Joel, leave a comment. There we go. Okay, Ethan has asked a great question. If we go with the AIN topics, how should we show us testing the monster or encounter? I'm going to say try to get a group of family together or run a game session online. There we go. Rosa, sure, I would be happy to put you in a group. Let me figure out a way to do that easily. What I'll probably do is just put out a call for who has already picked folks to be in a group and who would like to be in a group together. I'll figure out a way to do that. Can I give an emoji in here? Nope. Okay. Oh yeah, Edie's asking, do we have to have a separate topic? I'm going to relax that. Feel free to grab. You can claim the same topic as another group. There we go. Excellent, excellent, excellent. Let me see. Let me make a note to myself here. Control-Alt-M. How about I create a group sign up? There we go. How about there? That'll be my reminder to do that later, Rosa. So anyway, yeah. So along the way, please bug me with questions. This is the part of the semester that I love, because this is where I get to see what students are thinking of, and this is where you get to do something original. So I'm expecting to get questions from you probably about once a week on the final project. And then finally, at the end, I'm asking you to develop just a 5-minute presentation about the results of your project. 5 minutes is not a long presentation. That's just 5 to 10 slides. If you spend a minute, down to 30 seconds per slide. That should be pretty straightforward. What we will do is present those. I've got those down for April 15th. Let me take a look at, should this be adjusted? Question mark. Now that we know we are not returning to campus by then. But basically what we'll do for that, we'll create a Google Hangouts that allows you to share your screen. So if you just have your presentation available, you'll be able to share a screen. If you even run into issues with doing that, if you want to put your presentation in a shared folder, I can open it and click through for you. We will figure out a way to make that work. I suppose if you also want to make a video instead of delivering a presentation, we can do that as well. We will figure out how best to work this by the end of the semester. Unless anybody absolutely wants to do this on April 15th, I'll probably move this to April 20th. I meant to put that at the same due date as the letters home, but we'll see. The presentations are going to be graded just based on completeness. Did you present a background? Did you show us your methods? And did you show us the results? I'm not going to assess on slide quality or any of that. but of course the 8x8 rule, as always, is encouraged. And I'm not going to require a written report for this. It should be enough for us to present together. So that's cutting down your workload on the final project compared to how it would have been. All right, I'll pause for a second if there's any other questions so far. I'm just going to review our chat window. Okay, cool. I think I've gotten to everybody in chat. If I have not, please ping me again. Okay, so with that said, we're going to have a little bit of adjustment to how we handle quote-unquote class because, you know, we do need some interaction together. So what we're going to do is we're going to have 3 opportunities to meet a week. You are not required to come to these. You can view them after the fact if you need to. First is the class live stream. That's going to be each Wednesday at 2. And that's just here on the Let's Code physics page. And basically what I'll do there is provide a little bit of background about each topic, give you some tips on completing each activity. If I can get the link early, I will email it to you. I was able to do that today. I figured out how. But otherwise, you just come to the main channel page and it'll be the thing that is live. Let's see. Kwong has got me a question. Let me answer his. Who submits power for his presentation? Kwong will figure that as a possibility. Yes, there we go. So today we're going to talk about rolling, which is one of my favorite topics. Then next week we're going to talk about gravity and space, one of my other favorite topics. And then basically from then on we'll still meet, but I'll just do a recap of the previous topics for anybody that's still confused, and we'll discuss a little bit more about the final project. And then on Mondays and Fridays at noon, that just seemed to be the most available time consistently for me. I'll send a link to a Google Hangouts chat where we can chat live back and forth. The comment section on the YouTube forum is fine, but I think being able to talk face to face virtually would be a little bit more helpful. The downside of the Hangouts is I don't have a way of recording the Hangouts, because if I run Google Hangouts and my recording software at the same time, neither of them will work. So this live stream is kind of is basically a compromise there so that we can have an archive for it later. So anyway, like I said, please feel free to contact me. I've got those blacked out here since we are streaming on the internet, but you can copy and paste those as you need to, and I will also unredact those once we are no longer live. So anyway, with all that said, I do want to give another opportunity for questions before we move on to talking about the topic for today, about rolling motion. Okay, I'm not seeing anything else come up in the chat. So let's move along to talk about rolling motion. So like I said, this is one of my favorite topics. Edie says class is being canceled for Friday the 20th. Yeah, I mean, I don't know how one cancels an online class that doesn't meet synchronously. So I'll still have those available. They're not required, so I don't think it's an issue? Question mark? Yeah, I see Edie put canceled in quotation marks. I'm glad JU is giving y'all time to get off campus. I'm happy for that. I'm shocked that there are people who are requiring y'all to be in a particular place at a particular time. That is not the way this really works. But anyway, that's probably stuff I'm not supposed to say in public in front of students. So anyway, yes, I'll still be available. So anyway, let's talk about rolling motion. So we've talked about translational motion, where objects move from one point to another. We've talked about rotational motion, where objects spin around on an axis. If you combine those two, you get rolling motion. Like we have Ralph here is rolling down the hill. You can see he is rotating around and he is also translating. And so literally rotational motion is just rotation plus translation. Let me show you how this works out mathematically. I'm going to head over to our Jamboard here. If you see there's a few of you that have already joined that, that's wonderful. So the way it works is that you imagine that you have a wheel, or it could be a disc, or it could be a ball, or it could be something that isn't even really circular, like I've drawn a rock, not really a wheel. So when we think about this thing translating and rotating, we've got its translational motion going this way. So we've got V here for the translational motion. And, Jamboard link, copy and paste. There we go. And so when we've got this thing rotating, right, we have to think about a rotational velocity, right? So the way this works is we have to think about combining these two somehow. So the way this works out is if this thing is rolling without slipping, if it's rolling kind of nice and tightly on the ground, we've got the linear velocity equal to the angular velocity times the radius of the thing that is rolling. Right? This is a wonderfully simple equation. It tells you that if you want to know how fast the thing is moving forward, you take how fast it's turning around and how wide it is. Right? So this, for example, is why monster trucks tend to move at a different speed than regular trucks, right? Because they have a different radius for their wheels. What makes this interesting, the reason I love this as a mathematical thing, let's zoom in a little bit on the wheel here, is I want you to imagine a point, let's say at the top of the wheel, right? So this thing has two things contributing to its velocity, right? It's got the translational velocity, V going this way, and it's got the so this is V here, and it's got the R omega, R times omega, there we go, going this way. And what happens is if you add those together, you end up with this top point going at 2 times the speed. Right, so you can kind of think of it like this, like the wheel is kind of pivoting around the point on the bottom. And so this point has to travel faster because this point here in the middle is not rotating at all, right? It's just, the very central atom on this thing is not rotating at all. It's only moving forward with V, right? So the top is going at 2 times the velocity. The middle is going at just the velocity. Let's do this. In the chat, tell me, what speed do you think this bottom point is going? Put that at a question mark. The top's going at 2 times V. Middle's going at V. What speed do you think the bottom point is going? Tell me in the chat. All right, we've got a few votes so far. All of our answers so far is the same. Does anybody want to argue for a different one? Okay, we're starting to get some votes for 2V. Ooh, I got a few negative 2Vs. That's interesting. All right, let's take a look and think about it. So remember, this thing has Gabe, infinity. That's great. Okay, so let's think about this. We've got a forward going velocity of V, but then if I think about this thing rotating, right? Remember, it's rotating around like this, right? This is how omega is going. So at this point, the omega R piece of it is going this way. So I've got a negative omega R because it's going to the left. But we already know that omega times R is the same thing as V. And so that means these two, here, let's change our color for dramatic effect. That means these two exactly cancel. And so the bottom point is moving with 0 speed. So congratulations to everybody who guessed a speed of 0. Your intuition was astounding. And really it makes sense, right? Because if I go from here to here, I go from 2V down to V, right? Let me try this laser pointer option here. So I got a 2V here, and I got a V here. So it's like if I go from the top to the middle, I've lost a V. If I go from a V down from the middle down to the bottom, I have to lose another V, which means I end up down at 0, which seems really weird. This is the thing that a lot of students kind of push back against and say that, no, it's got to be moving, right? But think of it this way. What I want you to imagine now is instead of a wheel, let's imagine we had a tank, right? So here is a tank, and at the bottom of the tank is tread, right? If you look on the bottom of the tread on the tank, all those treads that hit the ground, they are stationary. They're not moving anywhere, right? And so, because you don't want your tank tread to be slipping and, kicking up dirt and everything. And so the bottom point of the wheel, thank you, Connor, I appreciate that. So the bottom point of the wheel is actually stationary. And so they actually depict that over here in this diagram. They've got several different points. Here we're traveling at 2 times the velocity. Here we're traveling at just the velocity. Here at point Q, we're actually traveling somewhere in between. Here we're traveling somewhere less than V, somewhere less than V. And at P here at the bottom, it's exactly 0. Now, assuming, right, there's a big asterisk on this. This all assumes that we are rolling without slipping. So when you are rolling a bowling ball, for example, and you're trying to do that trick where it curves in the lane, I can never get it to do that, there you are rolling with slipping. So this diagram just goes out the window completely. But for nice, safe rolling, like you want your car to have on the road, this is the type of scenario that you want. Because if your car is moving without the wheels rotating, that's a problem, right? You're either skidding or hydroplaning or just plain stuck in the mud. Yeah. The other reason this becomes interesting, and this is the thing you're going to look for in your video for this week, is this produces a very interesting mathematical shape. What you can do is trace the motion of a point on the outside of the wheel or disc or whatever it is, right? If you trace the motion of that point, right, it's rotating around, but it's also moving forward, you get this interesting shape called a cycloid. Cycloid is basically what you get if you combine spinning around in a circle with moving to the right. That's literally it. There's you can get into some more complicated math behind it, but basically it's what you get if you combine spinning in a circle with rolling forward. Let me show you how this works. The interesting piece is when we reach the bottom of the cycloid, when we get to this corner here. Now, I've learned that they've stopped teaching this feature in Calc 1 and Calc 2, which I'm very sad about, but this is what we call a cusp. Let me show you where this cusp comes from. C-U-S-P, cusp. All right. The way this works is we're looking at the trajectory, right? So we're looking at this cycloid coming around like this, and we want to look at what happens. Let's change my color here. We want to look at what happens at this point right here. So we're looking for the slope, right? We're looking for the dy dx. This is not a combination we often use in physics, right? Usually we're at dy dt or dx dt, but here we're interested in the trajectory, right? We're interested in y versus x. And so we're interested in what's happening at this point in terms of the derivative. Well, there's a neat little trick you can do where this top you can say is dy dt. The bottom you can say is dx dt. Because really what you can do, and this is where the mathematicians are going to revolt against me, but this is where you can say that these dt's kind of cancel. The mathematicians don't like for me to say that. They like for me to talk in terms of limits and rates of change and product rules, et cetera, but really you're canceling the dt's. But really what that gets you is the velocity y component divided by the velocity x component, right? Because this is the velocity in the y direction, this is the velocity in the x direction. Now here's the problem, right? When we get to the bottom, we all agreed the speed at the bottom is 0 in the x direction and the y direction. So this thing, now the mathematicians are going to be really angry at me, is 0 divided by 0. Now dividing by 0 is a problem. It's a thing you're not supposed to do. But when you take 0 and divide it by 0, you're really in a lot of trouble because this could be infinity, this could be 1, this could be 7, this could be 0, this can be really any number, right? Based on how you take the limit, et cetera, et cetera. And so this is really a problem, right? So your slope there at that cusp is undefined. It's kind of the mother of all undefined values, right? When you take 0 over 0. So the slope at this cusp is undefined. And so it's a thing that mathematicians don't like, right? They don't like it when I divide by 0. And yet here it is. Every time I watch something roll, there's a cusp. Right? There it is in nature, occurring right before your eyes, a cusp. So the universe is dividing by 0 every time you roll something. It's actually pretty wild. So anyway, your goal in the activity for this week is capture something rolling. I don't care what it is. It could be a quarter, it could be a car wheel, it could be a frisbee. Just get it to roll, get it on video, and track a point along the edge of the disc. And your goal is to look for these cusps in the cycloid. Let's see. So yeah, so let's get a little bit more into the... Gabe asked a great question. How many revolutions do you need? That's a great question, Gabe. I would think, let's say 2 to 3, just to get a good data set. There, how about that? So one thing you'll want to do is make sure that the surface of the thing you're rolling on is flat. You can technically use an angled surface, but the physics becomes much more involved, and so you can use an angled surface for extra credit, but you got to actually do the math on it. I will tell you, I've had several students say that they are going to do the extra credit, and then they never actually get through the math. Courtney is asking, can I use a ruler instead of a meter stick? Yes, a ruler is just a foot stick. Winky face. There we go. Yes, so for getting the length, if you didn't take your meter stick home with you, which I'm guessing nobody did, right? Feel free to use a ruler or just anything you know the length of, right? So if you've got if you've got a television in the background and you know the diagonal across the television, that works, And really, honestly, at this point, we're more interested in the shape than we are in the exact numbers because there isn't that much math to do on it. You're literally just looking for the cusp. Okay, I'm going to take just a second to drink some water and would like to hear some questions before we take a look at how we're going to model this in VPython. Oh, there we go. Gabe that's a good idea. Use a folder divider. Yeah, I mean, if you've got a piece of paper, it's 8.5 by 11 inches, right? You can convert that to meters. I mean, literally anything you know the length of works as a length scale. Okay, I don't see other questions coming in through the chat. Mason, is the video I linked before a good example of the tank track thing? Mason, I don't see a link from you. I might have missed it. So feel free to resend. I am getting some chat comments twice, it looks like, so it's possible we have a little bit of issue there. All right, so let's take a look at how we're going to model this in VPython. Guys, you got to model it, right? Actually, we're going to have a little bit of fun with this one. So let's see. I'm going to go to full screen, and just to make sure everybody can see it, we'll go to medium size here. So you can see here, I've got set up a disk that is rolling, and I'm tracking a single point on the edge of the disk, right? So really, I've got 3 objects in here. Let me just rotate this a little bit. There we go. Actually, no, wait. I learned how to pan recently. If you do shift click is supposed to be able to pan. Oh, that might just be on glowscript.org. Okay, never mind. Forget I said that. We've really got 3 objects here, right? We've got the disk, we've got a radius, and then I've got a point at the end here. This was the best way I could figure out to make a rolling thing work. Basically what we're doing is we're rotating the disk, and we're keeping this little red dot at the same point on the edge of the disk, and we are tracking the trail of that red dot. And you can see it gives us a cycloid. It gives us a cycloid with 1, 2, 3, 4, 5, 6 cusps. The main thing we're going to control this is through the length of the track. That's kind of going to be the most important thing, and the radius of the disc. So like, for example, I can make the disc larger by changing disc radius. Joel has asked, do we need to know the weight of the object we use? No. You won't need any energy graphs. There we go. Very good. So let's suppose I take this disc radius and let's say we double this, right? So I've increased that to 1. We'll run. And you can see everything else changes. You don't have to change anything else about the disc, the rod, or the marker point, because they're all set in terms of the disc's radius. So you just change this one number in line 13, and we will and we'll be able to change this. Edie's asking, what graphs do we need? Let's say y versus x. And I suppose Vx versus time and Vy versus time, because that'll get you the trajectory and where the velocity equals 0. There we go. I think I have that in the write-up. I could be wrong. So anyway, so I've doubled the size of the radius. So you notice that my cycloid became longer, right? So I've only got 1, 2, 3, and a little bit more complete revolutions there. Whereas if I decrease this, I'll go from 3 to a much smaller one. Oh, that is too small, Brian. You made that too small. All right, let's go back up to 0.5. So I've gone from 1 to a half. You notice I get a lot more revolutions here, right? So for example, what I might be able to do, let's suppose I make this a 1 and click run. One of the things I might be interested in, for example, would be the length of one revolution, right? How long does a track have to be for me to go along one revolution? Well, let's set the disc radius equal to 1 to make that easy to work with. So you notice here, my track length is 20. That was just a nice large number that I picked. But if I set a track length of 20, I get 1, 2, 3, and a little bit more of a revolution. So I get just over 3 revolutions. I could adjust this track length to figure out how long it takes for it to go one revolution. So like 20 is too long. Let's try 15. All right, I made the track shorter. I'm trying to get down to 1 revolution. Okay, I'm already past 1 revolution. 2 revolutions, a little bit more. So I might cut that in half again to get, let's say 8. So let's cut it in half and round it up. All right, I'm getting closer. I've got 1 revolution there. I've got a little bit too much in terms of my path there. So let's poll the audience again. Quiz question. What do you think the length of this track is going to need to be in order for me to get 1 revolution? Think about what special number it might need to be. Let us know in the comments what length you think that track is going to need to be to get just a single revolution. All right, we're getting some answers in. All right, so I've got a couple. Let's see. So I've got a few coming in. I've got a few 2π's coming in. Those of you who are suggesting 2π or pi times something, why are you thinking in terms of pi here? What's motivating your thought behind why pi should be involved? Okay, so Ethan and Gabe are reminding us that this should be related to the circumference, because essentially what you're doing is unrolling the surface, right? Is you're unrolling the perimeter, and you know that the perimeter is going to be 2π times the radius, and the radius happens to be 1, right? So it should be the circumference of it. So if my disk radius is 1, this should be 2π times 1, so this should just be 2π. So let's try a 6.28 and let's see what we got here. Plus, you know it had to be about 6, right? And 2π is nearly 6. Oh, and look at that. Look at this beautiful thing we've got here. We've got exactly 1 revolution. You can tell because the red dot has gone from the bottom point all the way back down to the bottom point. So congratulations to everyone who guessed 2 pi. Those of you who guessed something involving pi were on the right track. This print window here, I should probably point out, this is something I've tried to look into. I don't know if it's significant, but basically what that print statement is showing is the length along the cycloid itself. So this is the length of the red arc. I have not figured out what that number is supposed to be. So if anybody's got some advanced mathematical knowledge about what the arc length of a cycloid should be, I would love to hear that and see that compared with the number that we've got here. So anyway, the thing that makes this work, let's go down to the loop to take a look at how this works. Basically, we're using Euler-Kromer method here to update the theta, to update the angle. So the disk's angle is getting updated by omega each frame. And then we just basically move all the stuff. So this is to move everything as kind of one ensemble. And then we basically, when we move it forward, we've got to have this disk.pos equals disk.pos plus disk omega times disk radius, right? This is V equals R omega right here, right? So if you break this part, if you break this one line of code, let's suppose I make it 2 times R omega, you'll no longer get a cycloid. You'll no longer get rolling without slipping. Joel, I see your question. I'm going to get to that in a second. You see here, actually, let's make this longer by a little bit. Let's change this back to 20. Click run. You see here how it's sliding forward too much, and your cycloid has actually gotten broadened out into this little U shape here, right? That's not how you want your car to be running. Similarly, if I make this smaller than 1, I end up with severe slipping, right? Imagine your car tire doing this. Right? Imagine you're driving on snow or something, and your car tire is just slipping in the snow while it's trying to push itself forward. This is the pattern it would take. It would double back over on itself, right? Isn't that what happens when a car spins out? And so the only way to get nice, safe rolling without slipping is for this number to be 1, is for the velocity to equal R omega and not times some other number. Cool. So Joe posed the question, do we need to change any value on the code depending on the object we use? Absolutely. So the first thing you'll want to change is the radius of the object. So, measure its diameter and divide by 2. You can change the track length if you want to. If you want to just set this to be the total distance that the thing traveled over, that's probably the easiest thing to do. But I think radius and track length, I believe those should be the only things you need to do. If you really want to get creative and change the texture on this thing or change the color on it, you can to make it match, but that's an aesthetic choice. That's not required. But I think radius and track length should be sufficient there. Okay, let me see. I think the comparison process should be pretty straightforward. Basically, when you're comparing this, there's not a whole lot to calculate. There's no energy graphs to make. There's no, there's no special point where it turns around and comes back or something like that. Basically, just count how many rotations does the wheel go through during the video and how many rotations does it go through in the animation. How many cusps do you see in the video? How many cusps do you see in the animation? You're literally just making a simple visual comparison of the thing rolling in the video and the thing rolling in the code, and it should be pretty straightforward. Yeah, and then in your letter home, just think about explaining how does rolling work, what's a cycloid, how do you know that this thing shows up as a cycloid. Joel asked, are the units in kilometers? We typically use meters. I hope you're not rolling something a kilometer wide. Explain to them what's a cusp, how do cusps show up, and how does the code make the wheel rotate. Just show them that, that Euler-Kromer stuff about all of that, and it should be fine. So anyway, that is the activity for this week. That's information about rolling. It's literally just translation plus rotation. I'm hoping this is a straightforward video for you to record at home wherever you are isolated. If not, the next week's video, week 11, does not require you to record anything. It doesn't even require any tracker. It's already got a video for you with results that you just match, because I don't think you can get too many good videos of stuff moving in space. Maybe you are better equipped than I am, but next week will be a pre-made video. So if this week's task list turns out to be a bit too much, a bit too complicated, you can definitely dive right into week 11. So that's all I had in my notes. I would be happy to take any more questions via chat, either about this week's content, anything we've done previously that you're still working on in a letter home, anything about how we'll conduct the class moving forward. Rose asked, if we can't download tracker, what should we do? I would, let's see, how about two options? One, borrow a family member's device. Two, jump right into week 11 instead. Three, actually, I suppose what you could do, Rosa, would be to collaborate with a classmate and obtain their tracker results. I don't know why I'm typing this instead of just saying it out loud, but we'll just go with that. Seth, is there going to be another live video this Friday? Seth, yes, over Google Hangouts, so we can talk to each other. It will not be recorded for technical and what do we call it? Technical and confidentiality reasons. Kwong asks, will you save this stream? Kwong, yes, it is. It will automatically be saved. There we go. And then Joel, fellow presentation live in Google Hangouts. Joel, yes, that's the current plan. We'll see how everything works out. Winky face. Okay, I think I got all of those. 1, 2, 3, 4 questions and 1, 2, 3, 4 answers. There we go. Marcus, if we decide to code for the final project, where should we make the code? Oh, Trinket should be fine. Just you're probably best off starting with a code we already have used. If not, you can start a new one. Just click on click on new Trinket glow script then code. Do you think JU would change the grading from letter grades to pass fail? That's a good question, Rosa. They will probably leave that up to individual professors. Without making any promises, as long as you kind of keep up with things in this class, I wouldn't worry too much for this one. What time is session be Friday? Cancel Friday, Monday. Let's see. So Connor, this is Friday is just office hours, not required, and plenty of other opportunities to participate. It'll be at noon. And I think I mentioned this before, but for Friday, I will email out the link to you so that we can all get access. Outline for the front of the presentation look like. Oh, Joel, I can put one together. Yeah, that's fine. Yes, I can put one together. Let me put a note for that in my outline here. This is why I'm so glad we can chat like this, because that's something I would not think to, I hadn't thought to do. So let me just add a little note to myself here. WBL, create a template / outline. Enter. Cool. Cool. Questions in chat seem to have slowed down, so I'll give another few minutes for folks to, I'll give till 3 o'clock for folks to submit other questions. You're also, of course, welcome to submit questions via email or on GroupMe, or you can call me at the number at the bottom of the update document. Yeah, I will try to be as reachable as I can while stuck at home. Depending on what the final project is, do we need to send you the link for the code track video? That's a good question. You can include a link to it in the presentation. How about that? Yeah, that's probably the easiest thing to do there. Yeah, I'm probably, unless I see something horrifically wrong in the presentation, I'm probably not going to dig through your code too terribly much. Honestly, all I want is, oh yeah, Sean, please go ahead. Please go ahead and ask a question about TechCom. There is, all I really want out of the presentation is to see what you come up with and to see some pretty results. I don't feel like it does any of us a lot of good for me to nitpick presentations to death at the end of the semester, especially this semester. Oh my goodness. Yeah, Sean, go ahead and ask about TechCom as well. I know there's about half of y'all make up about half of TechCom, so this is a perfectly fine venue for that. Kwong wants to know, we claim the topic on the list. Highlight and add a comment. Hey, let's check the projects list. How are we doing on those? I see we've got Mason's claimed one, and Gabe has claimed one, and Ethan has claimed one. So yeah, so Kwong, basically I've made this document where anybody can edit it. And so you can come on, you just click and drag over the one that you want, click on the comment button, and then just add a comment. I see we've already got, ooh, looks like somebody wants Minecraft there. Oh, Joel's added one manually there. All right. We're supposed to edit our presentation, written documents, and then you'll finalize our grades for them. Okay, so that's a great question, Sean. So I'm not grading the, for TechCom, I am not grading the individual documents and presentations. I am assessing how you have demonstrated your ability to communicate with them. And so basically what I'm looking for in the final presentation and document is for you to have shown improvement from the first one. Does that make sense? Cool. I see cursors moving around and comments appearing in the final projects. So let's see. Somebody is simulating a car collision. I've got 2 folks who would like to make videos so far. That's wonderful. I got one person who wants to answer how... I actually got 2 people who want to answer how do minecarts work. So Joel Valdez and... who is it that's claimed that one? Hard to tell. I think we've got 2 folks on the how do minecarts work. Feel free to collaborate on that one. We're going to find the link for that. Connor, you mean the final projects? Let me send that to you. Mason, I put the link of that tank video. Okay, yeah, let's watch a tank video. Let's take a look at this. I'll use this next semester. Let's see. View of it. Oh my gosh, it's going to be amazing. Okay, I can already tell this is going to be one of my favorite things in the world. Oh my gosh, look at that. Yeah, you can see that there you're moving twice the speed. Oh my gosh. Mason, this is perfect. This is the most perfect physics video I have ever seen. Twice as fast, 0 speed. Twice as fast, 0 speed. Oh my gosh, Mason, that is perfect. I am in your debt forever. I don't know if y'all are having fun with this format, but this is kind of fun. I might do this during the regular semester anyway. All right, let me bookmark this right away. Let's put it in folder. Yeah, I'll put it in my spring 2020 folder. Why not? If students are collaborating, how would we know who we are collaborating with? Oh, Joel, you're only collaborating if you volunteer, if you choose to. If you choose to, you can contact them via email, group me, office hours. I'll also post a sign-up sheet. I don't know. Okay, Joel obviously just got the answer audibly. I don't know why I'm continuing to talk. This is a different format. It's taken a while to get used to. All right, I think the flow of questions is slowing down. I'll take about another minute. I do want to thank you all for your time. We are at 3 o'clock now, so we probably need to formally close. I'll stick around for another minute or so to see if other questions trickle in. But thank you all for your time and patience as we got this set up. I'm looking forward to seeing your faces on Friday during office hours, if you were able to make it. If not, please, safe travels, safe isolation, etc. Again, do please let me know if there is anything that you need, if there's anything I can help you with, and I do hope you're able to weather the storm all right.